All right, hello everyone. Today we are talking about equivalence versus identity, which is some insight on how variables are stored. So let's just jump right into it. First, let's talk about what is equivalence. Equivalence is what we are checking for when we use a double equals. When mutable variables, like a list or a dictionary, have the exact same contents, double equals is going to give us true. It's the same for any other type of variable as well, but I just thought I'd point it out specifically for mutable variables because that's a lot of what we've been learning about so far. So if I have list 1 equals list 1, 2, 3, I have my list. List 2 is the list 1, 2, 3. Those two lists store the exact same thing. So if I print list 1 double equals list 2, I will get true, because those two lists are equivalent. If I change one of those variables, it's not going to change the other. So if I change list 1 at index 1 to 10, list 1 is different, list 2 is not different. So if I print the two of them, they are no longer equal because their contents are not the same anymore. All right, with equivalence in mind, let's talk about identity. Identity is when two variables are referring to the same thing. They are identical. So if list 1 is the list 1, 2, 3 again, and I make list 2 equal to list 1, then both of my variables here are pointing at the same list. They're both looking at the same place in my computer's memory. And so if I check, are they equal? Of course they are. They're pointing to the same thing. They're going to be equal to each other. Identical variables are always going to be equivalent, but as we saw before, not all equivalent variables are identical. In order to check for identity, we can use a new keyword. We can use the is keyword. And like double equals, it's going to give us true or false. Instead of checking for equivalence like double equals, though, my is keyword is going to give us true when the two variables are identical. So in my example here, list 1 and list 2 are identical, so if I print that, I will get true. So when I have two variables that are identical, changing the contents of one will change the contents of the other. So if I have my list 1 is 1, 2, 3, and my list 2 is list 1, again, I have two variables pointing at the same list. If I print them both out, they're both 1, 2, 3. If I change list 1 at index 1 to equal 10, like so, and I print them both out again, both of them have changed because they are identical. Changing one changes the other. If I want to make two variables stop being identical, I can do that by completely overwriting the value of one of the variables, like this. So let's say I have list 1 is 1, 2, 3 again, and list 2 is once again identical to list 1. I can print list 1 is equal to list 2, and list 1 is list 2. Both of those are true. Again, if it is identical, they are always going to be equivalent. If I change list 2 to equal to list 1, 2, 3, now they are not pointing at the same list anymore. Each of them is pointing at their own list. So even though they have the same contents, this one's still going to be true because they're still the same inside, but our second check is going to be false because they are no longer pointing at the same place. So this is most often going to come into play when we are using parameters with functions. When we pass a parameter to a function, the local and global variables are actually identical. They're both pointing to the same place. But the thing is, when we pass an immutable value to a function, any changes to that local variable will break the identity as soon as they happen, because we're not allowed to change the contents of an immutable variable. All we can do is completely overwrite it with a new value. When we pass a mutable value to a function, though, like a dictionary or a list, we don't break the identity unless we completely overwrite that local variable. And that's why lists and dictionaries act differently than any other value type when we pass them into a function. So let's look at an actual example. So I have my function called example, takes one parameter x. It's going to change x to equal 10. Outside I have x equals 5, so I'm making my global x, and it's thinking of the number 5. If I print x, I get 5. Then I'm going to call example with x. That's going to make my local x, which is going to be looking at that same position. Both of them are thinking of the number 5. Now this is a little bit different than how we have talked about parameters in the past, but where it lines back up again is when I change my local x to equal 10, that's going to break that identity, and local x is going to equal 10, where my global x is still 5. When my function finishes, my local x is going to fade away, and I print my global x, and I still have 5 in that box. And where that's different is when I have lists. So let's say my global x now is the list 1, 2, 3. If I call example of x, x is now going to be passed into that function. I'm going to make my local x, and it's going to be looking at the exact same list. So when I make a change at x index 1 equals 10, I'm going to be changing local x, but that's pointing to the same place as my global x. So changing my local x is going to change my global x. Even when my example function finishes and my local disappears, that change is going to persist, and my global x is going to exist still. And if I print x now, x is now 1, 10, 3. So I hope this clears up a little bit of confusion as to why lists act the way that they do. There we go.